In this video, we're going to look at some real-life applications of solving sequences and series. The first thing to note is whether you're dealing with a sequence or a series. And the way you would identify that is by looking at the phrasing of the word problem and see if they're asking you for maybe a specific term in a sequence, or if they're asking you to add a whole bunch of terms together. So if they're asking you to add a whole bunch of values, like maybe it's the total number of seats in an entire theater or a section of a theater, then that would be a series case. If they're just asking you to find how many seats are in one specific row of that theater, then that would be a sequence case. Next, after identifying whether it's an A sub n or S sub n formula, you would want to look at whether they're describing a change in terms as adding a number from one term to the next, or if it's multiplying by a number from one term to the next. Common examples of this for the arithmetic sequence would be adding seats to the number, adding a number of seats to each row in a theater. For a geometric one, that would be something like how your salary is affected when you get a, say, 5% raise year after year after year. You're multiplying by 1.05 if you're getting a 5% raise. And then the next pieces you want to look for, A sub 1 would be the starting amount or the initial amount you have of something. It might be the initial size of an object. So they'll usually say something about it being the starting value. That would be your A sub 1, the first term in the sequence. And n is going to be how many terms you have in the entire pattern. So if we're thinking of the theater example, that would be something like there are 50 rows of seats in the theater. If you're talking about the salary example that we're going to do, that would be something like, are you interested in your salary after 10 years? Then n is 10. You have 10 terms in that sequence. Now we will be using some of the same formulas we've covered in the last few videos. So like I said before, the explicit rule, that would generally be more useful for finding a specific term in your pattern. And the series rule is the one you'll use if you're trying to add all of those terms up. So this would be 1 year's salary versus all of your income over a certain amount of time, or one row number of seats versus the entire theater's section's number of seats. So let's talk about the theater example first. So what we have here is a section in a theater has 10 seats in the first row. So this would be my starting amount, which means that's what I'm going to call my A sub 1 value. Next, they mentioned that it increases by 2 seats per row. This isn't something that we're multiplying by. It is literally adding to. So if the first row has 10, the next row has 12, and then 14 and 16, etc. So I know that this value here is D. And the last piece we have, they want to know how many seats there are, not just in row 18, but in the entire section of the theater. So all of the rows added together. This is going to be a series example with n equal to 18 in this case. So we know we want to use the series formula. So for the series formula, we need to know how many numbers there are, the first term and the last term. Now the problem is we're currently missing that last term in the sequence. So when something like this happens, we need to look back at the explicit rule, because I can solve for the last number in the pattern by using this formula instead, as long as we know the first term, the number of rows, or the number of terms, and the difference value. And we do know those three numbers. So I'm going to use this formula first to solve for A sub n, and then I'll be able to plug in A sub n and my other two values to solve for the sum of all the seats in the theater. So let's solve for A sub n first. In this case, A sub n is going to equal my initial number, 10, plus n minus 1 times the difference. So if I simplify this, remember we need to do the operation inside the parentheses first. So this would be 10 plus 17 times 2. And then we need to multiply before we add. So this would be 10 plus 34, which means we have 44 seats in that 18th row. So that could have been the word problem by itself, in which case we would be done. But this one didn't just ask us for the number of seats in that row, they asked us for the seats in the entire section. So now we're going to use the sum formula, and it's going to be S sub n will equal, I'm adding up 18 rows worth of seats, and then it's going to be the average of the first row and the last row combined. Now you could simplify this in several different ways. Probably the first way that would occur to people is to add the numbers on top here first. So now I have 54 over 2. And then it doesn't actually matter which number you divide by 2. So you can do whichever one you find easier in this case. So if I leave this as 18 times 27, then at this step you would probably just want to grab a calculator for this. The sum we should get in this case is 486. So I have 44 seats in that 18th row, but I have 486 seats in the entire section of the theater here. Now let's look at a geometric example. Another very common setup for dealing with sequences and series has to do with a person's salary, because a person usually gets an annual raise every year. So let's look at what terms they have defined for us here. My starting salary, so this is what I'm beginning with. This would be the first term of my pattern. That's going to be my a sub 1 value. Now, the 7% raise is something that gives a lot of people trouble. They are inclined to think that r is equal to 7 in this case. But what we want to remember is that we're starting from 100% and we're adding 7%. So we're getting 107%. But when we're dealing with operations like multiplying, we actually want to have this number in decimal form. So my r value here is actually going to be 1.07. That's the decimal form of showing a 7% increase to something. So that's what you would use if you were trying to figure out what your raise will be after receiving a 7% raise. And then the last number they've given me here, we're looking at our income over 12 years, not just our income in the 12th year specifically. That would be a sequence. This is adding all of our income up over the 12 years, but my end value is 12 either way. So what's important, since we're not just finding an initial salary, we're finding the total pay over 12 years. That's why I know that this is a series formula. Now, for the series formula, the numbers we need to know are the first term of the sequence, the r value, and the n value. And sure enough, we have all three of these. So in this particular problem, I'm not going to need to use the explicit rule, because the sum formula does not use that a sub n term. So this is pretty common when you're dealing with the geometric series. So I'm going to go straight into saying s sub n is equal to, and I am going to have to do a lot of these numbers with a calculator, so I have them written down in advance here. So my initial value was 60,000. And then remember, we're multiplying by 1 minus r to the n over 1 minus r. So you want to be careful at the order that you type these things in, because we have to follow order of operations, PEMDAS. So I need to make sure that I'm doing the 1.07 to the 12th power first, and then I can do 1 minus that number. If you calculate that step, you should get, and this is going to be a decimal, so I'm just going to write a few of the digits in this. You should get something around negative 1.25219. And the decimal keeps going on, so I'm just going to stop it there. But on future calculations, make sure you use the entire number. Don't round it off. Always try to use the entire value that you have as much as possible to be more precise. Next step here, we would want to do this multiplying step. So now I have 60,000 times the negative 1.25219 number. Just to give myself a little more space, I'm going to come back up here. So that number gave me negative 75,131. And again, there's a decimal that goes on for a bit. That's a 5 right there. And I'm dividing this by negative 0.07. So then your last step would be to divide that number by the negative 0.07. So your final answer should be that this comes to 1073307 and 8 cents. So we ended up with $1 million, a little over $1 million, after working at this company, starting with $60,000 pay and earning a 7% raise every year for 12 years total. That's not your pay in the 12th year. That would be a sequence instead, the a sub n value. This is the series adding all of our pay up for 12 years. So that's it. A lot of the word problems just come down to paying attention to whether you're dealing with finding a specific term or finding the sum of all the terms, and then making sure you're also able to distinguish between it being an adding pattern or a multiplying pattern. Everything else from there is just, do you have the numbers you need to go straight to the series rule? If you don't, you might need to use the explicit rule to solve for a missing value first. So that's it for this lesson. I hope that will be helpful on the assignments.